Hi, welcome to section 8.5, 3 theorems involving proportions. Our objective is to apply 3 theorems frequently used to establish proportionality. For homework, we'll be working on page 354 to 356, numbers 1 to 15 odds, 18, 20, 22, 26, and 29. First, we have our side splitter theorem. If a line is parallel to one side of a triangle and intersects the other two sides, it divides those two sides proportionally. So here's going to be what it looks like. We start off with a triangle. In that triangle, we have a line going through that's going to be parallel to one of the sides. What we have left here is we have these sides that are actually split, hence the name side splitter. We can break those up into 4 pieces and set them up proportionally. I'm going to do top over bottom equals top over bottom. X over Y equals Z over W. And that's going to be how the side splitter works. For our next theorem, it says, if 3 or more parallel lines are intersected by 2 transversals, the parallel lines divide up the transversals proportionally. So let's take a look at what that looks like. First and foremost, I'm going to start off with 3 parallel lines. So I have my 3 parallel lines and my 2 transversals. What happens here is we end up with pieces in between our parallel lines. I'm going to label them XY, ZW. What this theorem says is that, again, if we're on the same transversal, we can set up those pieces in between the parallel lines as a ratio and get a nice proportion. And that's how this theorem is going to work. Our last theorem is the angle bisector theorem. That says, if a ray bisects an angle of a triangle, it divides the opposite side into segments that are proportional to the adjacent sides. So here we go. Let's start off with a triangle. So if I have a triangle, and I know one of the angles is being bisected, it's either given to me it's bisected or I have the tick mark showing it's being bisected. What we have is we have a side that's being split into 2 pieces. Not 2 equal pieces necessarily, but 2 pieces nonetheless. We're going to call this X and Y. Now, we have the other 2 sides of our triangle that are untouched. I'm going to call that Z and W. What the angle bisector theorem says is if you take that side that's being cut by the angle bisector, again, remember, being cut doesn't mean in half, just being cut, we're going to make a ratio out of that, X over Y. The 2 sides remaining also get set up as a ratio to form a proportion. Since X is the top of one ratio, its adjacent full side of our triangle is going to be Z, and since Y is our bottom, our adjacent full side is going to be W, so it's also on the bottom. And that's how the angle bisector theorem works. Okay, so for our first example, we have if EB is parallel to CD, find ED and find CD. So here we go. As long as we know that we have those parallel lines, we know we can set up the side splitter and solve for piece ED. So here we go. Let's make our proportion. 4 over 6, one set of sides, equals 5 over x, our other set of sides. And let's cross multiply. I end up with 4x equals 30. When I divide both pieces through by 4, I end up with x equals 7.5. X is going to be segment ED. Now the second piece that they want is segment CD. So we'll put a Y right there. Now, I don't have any angle bisectors here, so I don't have angle bisector theorem, nor do I have that second theorem with the parallel lines. You have to remember that sometimes you still need to use similar triangles, so I'm going to go over our similar triangles. We have this top little triangle, 3 full sides, and I also have this big triangle. Again, 3 full sides. We can set up the sides of similar triangles proportionally as well. So here we go. I'm going to do left side over left side. So I have 4 over 10. Full sides of our little triangle, full side of our big triangle, equals 6, the bottom of the little triangle, over y. And I cross multiply. 4y equals 60. Divide both sides by 4, and y is going to be equal to 15. Segment CD is 15. So don't forget about similar triangles. At times you're going to still need those. For our next example, we have if line I is parallel to S is parallel to A is parallel to B, and EL is 32, we want to actually find X, Y, and Z. So here we go. Here's what we know. EL, this whole piece right here is going to be 32. Now, we're trying to find all the pieces over here. And the one thing we know is that the parallel line theorem, we have to match them up. And the problem is, we don't got much to go off of. So here's what I would do. First and foremost, let's find out what the distance is between the parallel lines on that first transversal. The total distance that we're spanning, 8 plus 6 plus 10, is going to be 24. Let's make a proportion out of the total distances. 24 over 32. Let's reduce that, both divisible by 8. That gives me 3 over 4. Let's make some ratios now, using our pieces in the middle here. 3 over 4 equals 8 over x, and let's cross multiply. 3x equals 32, so x equals 10 2/3. Let's do the same thing with our y. 3 over 4 equals 6 over y, and let's cross multiply. 3y equals 24, which means y is going to be equal to 8. And our last one, let's solve for z. 3 over 4 equals 10 over z. 3z equals 40, which means z is going to equal 13 1/3. And let's just double check. 10 2/3 plus 8 plus 13 1/3. Does that equal up to 32? It does. And let's just double check with some ratios, and we're just going to use our calculator real quick. What's 8 over 10 2/3? It's 3/4. What's 6 over 8? 3/4 again. And what's 10 over 13 1/3? It's 3/4. All those ratios of segments between parallel lines are equal, which is how we know that parallel line theorem is being applied. And another example. If angle EMD is congruent to angle AMD, let's put those tick marks in. We're trying to find the length of segment AE, this total distance. Now, I see that I have an angle bisector, so let's apply the angle bisector theorem. It said if you take those sides, that side that's being split, I'm going to let this piece right here be x, you can make a ratio out of it and set it equal to the ratio of the adjacent sides. I'm going to solve for segment AD first. 4 over x, so I took that split side and made a ratio out of it. Now I'm going to set it equal to the corresponding adjacent sides. 4 was adjacent to 8, and 10 was adjacent to x. And let's cross multiply. 40 equals 8x, which means x equals 5. Remember, they don't want to know what AD is, we want to know what AE is. AE, the total span of that, is going to end up equaling 9. For our last example, we have a proof. So here we go. We're going to start off with our statements and our reasons. Knowing that we have NR is parallel to TI, an angle, and TR is congruent to angle NRT. That's what's given to us. Let's put in our markings. We have parallel lines, and NTR NR is congruent to NRT. The first thing I notice here is that's one triangle with congruent angles, so I know what neat means I'm going to have congruent sides. But let's kind of think ahead a little bit. Also have parallel lines, that NR is parallel to TI. Now, let's go ahead and see what we're trying to prove. That BN over NR is congruent to BR over RI. That doesn't make any sense at all. So, let's see what we can do. If we have a BN on the top of one and a BR on the top of the other, and then the NR is going to be one of them and RI. Let's start off with our side splitter. Let's say BN over NT equals BR over RI. And for our reason, let's do side splitter. Now, for this, we have the BN part of what we're trying to prove, the BR, and the RI. We gotta work in this NR, and I gotta get out this NT. And what I'm looking at in my triangles, those are the sides of my triangles that are opposite the congruent angles. Let's say NT is congruent to NR if sides then angles. Now, as long as we know we have congruency, one can replace the other. So I'm going to take that NT, and I'm going to replace it with NR. BN over NR equals BR over RI by substitution. Now I know this is the part where I usually have your homework answers. I'm super sorry, but I don't. I'll make sure that they're up by Monday when we're working on them in class. Have a good weekend. That's unfortunately my baby girl who's sick. Say hi, Kira.
Hi.
We're sick today, which is why we weren't at school. So sorry about that. Have a good weekend, and I'll make sure I have these answers up on Monday. And as always, have a good one.